All right, so we've talked about the shapes. Now let's do some transformations with these conic sections. Translation, if you recall, you're not changing the shape or the size, you're just either moving it left or right or up or down. Rotation, same thing, you're not changing the shape or the size, you're just rotating it around the axis somehow. Let's translate this ellipse. Okay. We're going to apply a translation of 3 comma negative 4. What that means, well, first off, let me rewrite it correctly. That 3 negative 4 should be a subscript. The number in front is what we're adding to the x value, and this is what we're adding to the y value. Okay, so we're obviously subtracting from the y value. All right, well, if you think about this, the center right here, this we can pick out as negative 2, 1, right? So let's look at it this way. We have this factor, we have x plus 2. All right, well, we know that it starts at x equals 2 for the center, so we set that equal to 0, and we get x equals negative 2. Well, if we're translating that 3 units, that means 3 units in the positive direction to the right, well then I'm adding 3 to that value, which gives me x equals 1, which makes my factor no longer x plus 2, but the factor, if x equals 1, would be x minus 1. Okay, so that's what goes there. We do the same thing for the y values. I have y minus 1, so that means that the y value for the center is 1. Well, if I'm subtracting 4, I'm moving that 4 units down. That means that my new center will be at, the y value will be at negative 3, which makes that factor y plus 3. And that's what goes there. Okay, so this is going to be our new equation. We have x minus 1 instead of x plus 2 squared. And again, it's just being translated. It's not changing its shape. So the 16 and the 9, the a squared and b squared don't change. And that will become a y plus 3 squared equals 1. And graphically, it would look like this. Now let's move that there. All right, well, like we've said, we were starting off here. We had negative 2, 1. So negative 2, 1 was our original center. And we now are saying that it's going to be over here. It's going to be 1, negative 3. Well, let's see. That would give us a 1, negative 3 is right there. And that does make sense because we are translating it 3 units to the right and 4 units down. All right, let's rotate now. Let's rotate an ellipse about the origin. Okay, so visually speaking, we're going to start off with this orange ellipse here. And we're going to rotate it. In the example, we're going to use 60 degrees. Okay, so if I were to rotate this up 60 degrees, okay, that would give us this blue ellipse. And we're going to find the equation for that blue ellipse. All right, well, let's write down, I said we're going to use a theta of 60 degrees. And the orange ellipse in that picture we just looked at is given by this equation right here. Over here, you're going to notice that I have some formulas. These are given to you on a quiz or a test. You don't have to memorize them, but you certainly need to know what to do with them. We're going to direct substitute in for x and y, okay, with those values. So I'll leave them up over here. All right, now you don't have to do this, but the first thing I like to do, I know how much people love fractions, so well, let's get rid of them. I am going to multiply the left side by the common denominator and the right side by the common denominator. And that is going to give us a 1x squared. Don't forget to distribute. That is going to be a 4y squared, and that equals 4. Okay. Now, let's substitute in for x. X equals x cosine theta. Our theta in this case is 60 degrees, plus y sine of 60 degrees. And that x value is squared, plus 4 times the y value squared. So the y value is negative x sine of 60 degrees, plus y cosine of 60 degrees. And that is squared. And I'm running out of room, so let's make that smaller. And that equals 4. Okay. Now, if you look over here, this is nothing more than the coefficient for that x and the coefficient for that y, and the same thing for over here. They have values, the cosine at 60 and the cosine of, and the sine of 60. You should remember that the cosine at 60 is 1/2, and the sine at 60 is the square root of 3 over 2. For demonstration purposes, I'm going to hold off on the exact values and just use the decimal value on your calculator. So the cosine at 60 is 1/2, so we can call that 0.5x. Okay, and the sine of 60, if you plug it in, that is the same as the decimal 0.866 y, and that value is squared. Plus 4 times sine of 60 is, oh, don't forget about this negative right here, so that's going to be a negative 0.866 x plus a 0.5 y, and that value is squared, and that equals 4. You FOIL it out. If you prefer the Punnett square method, do it. I don't care. You're going to get the same answer. To save time after you FOIL it, you are going to get these terms. You're going to get a 0.25x squared plus a 0.866 xy plus a 0.75 y squared. And over here, you're going to get plus 4, and then that is 0.75x squared minus a 0.866 xy. That's an xy right there. And plus 0.25 y squared. 0.25 y squared. And that equals 4. And I'm running out of room, so let's just shove an equals 4 in there, okay? All right, now, don't forget, we have to distribute this 4 still here. Distribute, distribute, distribute. So let's do that. You're going to get, well, here, let's just save time. After you distribute this 4 here, here, and here, and don't forget, you always combine your like terms. After you combine your x terms, you're going to get 3.25x squared minus a 2.598 xy plus a 1.75 y squared equals 4. And that is the equation in general form for that blue ellipse that we just rotated 60 degrees. All right, what if we're asked to work the other way now? What if we're given the equation and we're asked to find the angle of rotation about the origin? Okay, well, let's do that. Here is what we need to follow. Oh, before we talk about that, let's remind what A, B, and C are. So in general form, ax squared plus bxy plus cy squared. Okay, so that's what we need is A, B, and C. So in this case, A is 9, B is 4, and C is 6. All right, well, the first thing I want to do is to find the angle of rotation. If A and C are the same, well, if A and C right here are the same, then my angle is always a constant 45 degrees. Okay, that's easy enough. But I notice that in my example right here, my A and C are not the same. All right, so it looks like I'm going to be using this formula right here. Now keep in mind, every angle, you keep going around 360, you're subtracting 360, and you have infinitely many different values for each angle. The 2 theta we're going to keep in between 0 and 360. All right, so let's move that up there and continue. So I'm using the tan 2 theta equals b over a minus c. Well, my b value is 4, and a is 9, and c is 6. All right, oops, that's not 20, 2 theta. All right, so that gives us a tan of 2 theta equals 4/3. Now, if you recall, we want to find this angle value. So the angle value, which in this case is 2 theta, equals the arctan, which you also know as second tan on your calculator, of that value 4/3 will give you the angle value. Okay, so let's see what happens. So you plug that into your calculator, and I'm just assuming you're in degree mode, so let's go with the degree value. That's going to be 53.13 degrees. Great. Now we don't want 2 theta, we're trying to figure out theta. So now we get rid of the 2 by dividing by 2. Okay, and over here, theta is going to equal this value divided by 2, which comes out to be 26.57 degrees. And so the general form for any of these conics that we've been talking about looks like this. We can have ourselves an x squared term, an xy term, a y squared term, an x to the first term, a y to the first term, and a constant set equal to 0. There's our coefficients in order, a, b, c, d, e, f. I say we don't have to have all these terms. If we don't have a term, say for example we don't have an xy term, that simply means that our b coefficient equals 0. Okay, so keep that in mind. Now we've talked about ways of looking at this and identifying what conic we have. There is another way of doing it. It's using the discriminant. So let's talk about that for a minute. You may remember the discriminant as b squared minus 4ac. Okay, there we go. All right, well, that's a numeric value. So there's 3 scenarios. That value is going to be negative. It's going to be less than 0. Or it's going to be positive, greater than 0. Or it's going to equal 0. All right, well, if it is negative, if it's less than 0, we have either a circle or an ellipse. Okay, great. So if it's negative, we have one or the other. How do we figure out which one we have? Then we go back to the coefficients of the x squared term and the y squared term. And, well, if they're the same, we have a circle. And if they are different, we have an ellipse. And we've talked about that. Okay, if it's greater than 0, if it's positive, well, that means we have a hyperbola. And if it equals 0, we have the other bola, a parabola. Parabola. Okay? Great. I didn't mention it before, but just so it's been said, this xy term, if you don't have an xy term in it, what that simply means is your shape, the axes in your shape are going to be parallel with either the x or the y axes. If you do have that xy term in there, that means that there is some sort of rotation going on around the axes there. Okay? Just so you know. All right, so let's see what we got here. So let's take this information and leave it right there. And let's, this is also true for the degenerate cases. I'm not going to spend much time on this, but it is pretty interesting. And I recommend you take 2.5 minutes and go to my conics folder. And right here, Sal the Math Guy, this 2.5 minute conic video will explain the degenerate cases. It's pretty interesting. Well, I think it is. I think you will too. All right, so let's do an example here. Let's say we have this conic. Say we have 9x squared plus 4xy plus 6y squared equals 20. Let's use the discriminant to figure out what we got. All right, well, in this case, our A is 9, our B is 4, and our C is 6. Remember, if you don't have an xy term, that means B is 0. All right, so B squared would be 4 squared minus 4 times our A value times our C value. All right, let's see what this gives us. I don't know what this is, but I'll tell you that 16 minus that's going to be a negative number. And that's all I really need to know. So going back here, It's negative, so we have either a circle or an ellipse. Well, if you notice, our A and our C are different, therefore we have an ellipse. Let's take a look at your outline. Today we worked on day 8, Transformation of Conics. So be prepared to come into class and work on page 575. I'll see you then.